Ladies and gentlemen, I actually feel a little bit dirty making a video about Nathan Oakley, but he published a video a couple of days ago about Coriolis, and I was quite stunned that someone that has been in this debate for as long as he has and supposedly runs a daily debate show still doesn't know what the Coriolis force is. So it was a pretty short video, and they bring up the usual examples like snipers adjusting for Coriolis, field goals being deflected by a third of an inch, that sort of stuff. And then they just wave it away because they have this horrible understanding of what Coriolis actually is. I found it pretty funny because the most blatantly obvious effect of Coriolis is literally on the screen right now, staring them in the face. Anyway, what they think Coriolis is this stupid idea that you could get in a helicopter in New York, take off, and just hover in the air for a couple of hours, waiting for Los Angeles to rotate towards you, and then you land. And this idea really comes from their utterly shithouse understanding of reference frames in physics. So yes, Nathan, like we keep telling you, you do need two reference frames to understand Coriolis. And those two reference frames are not the Earth and the atmosphere. The two reference frames are the inertial reference frame and the rotating reference frame. Now, obviously, an observer stuck on the Earth is rotating, so that's fairly easy to understand. So he can be in our rotating reference frame. That doesn't mean that the atmosphere is therefore the inertial reference frame, nor does it mean that the atmosphere is stationary either. So the observer in the inertial reference frame, could just as easily be watching from space, and he could also be moving at a constant velocity. He just can't be accelerating or rotating. So I think we should run through an example of Coriolis, just so we're all clear on what it actually is. So let's say we're in the mountains of Afghanistan, and we're going for the world record sniper shot. So the sniper here at the bottom is at 34 degrees latitude, and Osama bin Laden is sitting in his cave at 35 degrees latitude. Now the key thing to understand is that the sniper and Osama are at different latitudes and therefore have different tangential velocities. And that velocity is given by this formula here. So you could stick in the 3,959 mile radius in there and just divide it by 24 hours. And that's where the 1,000 miles per hour at the equator comes from. But I'll get my speeds in meters per second. So if you plug in Osama's latitude of 35 degrees, he's moving at 379.52 meters per second. And if you plug in the sniper's latitude of 34 degrees, then he's moving at 384 meters per second. So the sniper is actually spinning about 5 meters per second faster than bin Laden. And that is how the Coriolis effect comes about. So what this looks like from the inertial reference frame, the sniper fires the bullet and it travels in a straight line. But because the sniper has a higher linear speed than bin Laden, then the bullet ends up hitting the goat. But obviously from the rotating reference frame, where everything looks like it's stationary, but actually isn't, then this will appear as a curved trajectory. And one thing that I really want to make clear at this point is that this has nothing to do with the atmosphere. So the exact same thing would happen if the Earth had no atmosphere whatsoever. So the bullet appears to curve because there is a differential in their tangential velocities. The way Nathan pretends to understand Coriolis is by saying that the Earth is the rotating reference frame, so spinning at 1,000 miles an hour, and the atmosphere is the inertial reference frame and somehow isn't moving at all. Now, if you think about this for all of 5 seconds, what this means is that if you're on the equator, you should be getting blown away by 1,000-mile-an-hour winds. So I actually went on Flat Earth Debate to ask him directly if this is how he understands Coriolis. And of course, no surprise what he actually said.
It is your assertion that we live on a ball. And it is also a fact that we must have two separate reference frames, which you have just conceded very quickly. So therefore,
Yes.
given the fact that we have two separate reference frames on your imaginary ball Earth, would you not expect there to be 1,000-mile-an-hour wind at the equator?
I would not. Would you?
Well, I would, given that
I
you
would.
have
You
a
would, okay.
hold on. You have a separate rotating reference frame in your imaginary world of ball Earth.
So there you go. And as is the case for just about everything in flat Earth, this is obviously a case where the hundreds of thousands of professionals, like meteorologists, oceanographers, even your fucking nightly news weather guy, just don't understand Coriolis. But some fucking muppet on YouTube just comes along and debunks their entire field. Anyway, and this is usually the point where someone goes, oh, hey, now you got to prove that the atmosphere is Velcroed to the Earth. And actually, we don't have to do that at all. So have a look at this grid. Across the top, we've got two possibilities. Either the Earth is rotating or it isn't. And on the left, either the atmosphere is rotating or it isn't. So there are only four logical possibilities. If the Earth is rotating and the atmosphere isn't, then we get 1,000-mile-per-hour winds at the equator. By the same token, if the atmosphere is rotating and the Earth isn't, then we also get 1,000-mile-per-hour winds at the equator. Obviously, in reality, we don't have 1,000-mile-per-hour winds, and therefore both of these are eliminated. So what we're left with is either a stationary Earth with a stationary atmosphere, or a rotating Earth with an atmosphere that rotates along with it. What all this means from a logical standpoint is that if we can demonstrate that the Earth is rotating, then it follows necessarily that the atmosphere is rotating with it. And just in case you numpties have forgotten, the Earth is rotating.
A 15-degree-per-hour drift.
Thanks, Bob. And just like the sniper's bullet, Coriolis also affects field goals. So here's Neil deGrasse Tyson's tweet from October 2015, where he calculated that the football deflected by 1/3 of an inch due to the Earth rotation. Now, I've actually gone and got the footage of that field goal, and I'm really hoping that Fox Sports aren't a bunch of cunts when it comes to copyright strikes. It's 13 seconds of footage from about 6 years ago. But I guess we'll see. Anyway, all I want you to note is where the kick was taken from and where the left upright is.
Good snap, good hold. It is good as he banks it in, and the Bengals are 5-0.
Right, so hopefully you saw that the kick was taken from the 32-yard line. And the left upright is at the back of the end zone. So I've opened up Google Earth and got the latitude for both of these points. So let's do what we did for the sniper's bullet and work out how much deflection there was. So we'll plug in those latitudes for both the kicker and the upright, and we'll end up with the velocity differential down the bottom of just 1.2 millimeters per second. Now, if you look at the field goal footage frame by frame, you'll see that the ball is in the air for almost exactly 2 seconds. So I calculate a total deflection of about 2.4 millimeters, as opposed to the 8 millimeters, or 1/3 of an inch, that Neil deGrasse Tyson got. And that's okay, he's allowed to be wrong sometimes. Now, the next objection that flurfers raise is usually something along the lines of, the Coriolis effect is an apparent deflection. It's not a real thing, so how can it have an effect in the real world? And you've even got Wikipedia calling Coriolis a fictitious force. So as much as QE is actually an idiot, it's not an idiotic question to ask how a fictitious force can cause real world effects like
Hurricanes, hurricanes, hurricanes.
Thanks, QE. So here's a tropical cyclone off the coast of Queensland, which is obviously in the southern hemisphere. So why does it rotate clockwise? First things first, hopefully everyone's aware that hurricanes and cyclones are basically just huge low pressure systems. And let's say we also have some high pressure air up to the north, as well as high pressure air to the south. And as we all know, high pressure moves towards low pressure to try and equalize. So on a non-rotating Earth, all that would happen is that the high pressures would move to the low pressure, and it would basically be windy for a while, but they would come together and cancel out. But with the Coriolis effect, these three air masses are at different latitudes, and therefore they have different tangential velocities. So the high pressure to the north will be moving the fastest, the high pressure to the south will be moving the slowest, and the baby bear low pressure system will be moving just right. So both high pressure masses will head towards the low pressure, but because of the speed differential, they are both going to miss to the left. Now, in the case of the sniper's bullet that we looked at before, that would be the end of it. It would just miss the target. But in this case, we've still got the principle of high pressure moving towards low pressure. And that means that as this high pressure mass coming from the south starts to lag behind the low pressure, it will start to curve towards it. Same applies to the high pressure mass coming from the north. It will get ahead of the low pressure mass, but it will also start curving back to the right because high pressure goes to low pressure. So you can kind of think of the high pressure masses as really slow bullets, and the low pressure mass is kind of like a magnet. So I'll replay that animation again, but hopefully you can see how this results in cyclones rotating clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. And that's really all I've got for you today. I think I've summed it up pretty well at the start anyway. You know, Captain Slappy's been in this game for coming up to 6 years now, and still doesn't understand Coriolis. You know, I wonder why that is. Let me know in the comments.